So today I want to talk about some special file systems in Linux, and we're going to talk about the procedure or the process file system, and give you a glimpse of what that actually entails. This is not something that is generally covered in uh, all courses in Linux, but this is a good time to introduce this. When we talked about the main file system, we've talked about the temporary file system. And now we're going to just jump in and talk about the process file system and what a process is. So, what happens when the system is actually running is that it actually has the kernel in memory and it is processing all of the requests through that kernel, and it is basically creating some status of itself and how it's running. Oh, one of the most common commands that I could use if I'm inside the terminal is the process command. So I'm going to just use it in a very simple way, and this command ps tells me all the processes that I am currently running. In this case, what I have is I have the two processes. In this case, 161, which is bash, and 398, which is ps. And if I use a different switch on that ps command, I can see all processes that are being run in the system. In this case, there is two init processes. One of these is my first process that was started by my first VM, and 168, which is TTY2. Now, one thing that we see is that question mark there on TTY on the TTY column. It means that it's not really sure what TTY that it's attached to, and that's because I closed the window. So I'm going to just go ahead and kill process 1, and we'll see what happens. I may crash my system. But no, I didn't. It just didn't kill it. Okay, so we can see that it is running init. That's just my initial initialization process that handled everything. But you can see that I have a new init process that's assigned to my terminal. So this also corresponds to, we'll look here at this uh, top command. And so you can see this is a real-time monitoring system of my memory. And I can look and see the PID, which is the program or process ID, and how much memory the process is using, and the user that actually started that process. So as you can see, that init process that started 160 that or 168, that is the um, initialization process that's running currently. I'm going to go ahead and quit that. Now, what we can do is we have a special operator in Bash, and that's the ampersand. So if I wanted to run the command that I just ran, and I append an ampersand on the back of it, and I can do it with a space or without a space, what will happen is I will effectively background that process. And you see that it is assigned and reports the process ID 485. Now, if I run another one, and I run it in the foreground, what we will see is there are actually two of those processes running in this case. So there's the first one that I started and the second one that I started, the one that I'm looking at right now. And if we use that, we can see that the first one only is the one that's running now because I quit the second one. But if I go and use top again and use that background character, then I have two of these processes running. And again, all that this process is doing is it's reading the memory information, memory map, and it's trying to find out how much memory a particular application is using. Okay, so now that I have those two processes, I can use a kill command to kill one, right? And it'll just stop it. And it says no such process. I guess that's because I'm having a hard time seeing the difference between a 0 and an 8. Okay, so let's see here. I'm trying to use the foreground command to get that job up into the... oh, it actually worked. At some point I killed it and it was gone. Okay, probably right here when I killed it right there. It just took a minute to leave. Um, but that process is gone. Okay, so there's still a top running. And now what we can do is we'll just look in the proc folder with my tree command, and I'm going to show that that process. And this is the actual folder of the proc file system where that process is running. We can see here that these are the file descriptors, and remember that's 0, 1, and 2, which is input, output, and error, and all of them are currently set to use the terminal 2. But I could send the process that I'm running in terminal 1 over to terminal 3, for instance. And we can do that and actually play around with it with the redirection. So what I'll do is I'll go ahead and launch another terminal, and I can look and see which one is running, and it's TTY1. And so I'll just go ahead and send the output from the tree command over to the device TTY1. And notice that that's exactly what happened. So when I switch over to TTY1, I actually see that output coming right over. Now, what did it give me? We can see it here. It gave me that exact output, and I saw it over here on this TTY. Now, if I look at what I looked at before, which was the Proc 485 or 405, there's my output. All right, so I can push that over to any device, even if it's a block storage device or a terminal. Um, the output can go over, and that's a form of redirection. But again, as you can see, I'm querying this process file system, and because I have gone in and I have actually queried through the 485, and I can see the command that was used, the current working directory. I can see the command that was used to create it. This is the top process, and I can see the file descriptors that are listed here. And sometimes a process will actually write to the process file system, and you'll see a file descriptor number 3 that designates that process. So there's quite a bit of information here that we can look at, and that's some of the stuff that top will actually go and find in that process file system. So when I use that process job and I see what processes are running, this shows me the execution time as well. And I can use uh, a program like kill, which would send a kill signal over to, in this case, my top process, and I'm just going to kill it. It's going to take a little bit to kill it. The better way, instead of looking at this over and over, is I might want to do a tail of the proc file system and look at this 405 folder and see if I can find out if that file exists, to find out if a process actually closed or not. So that may be one way to do it. It's still running. I'm going to use super user do to kill that one. Now notice that if I go over to TTY1 and I do my process command, and I'm not the terminal that's assigned that process, so it will not show up. I have to use the -A switch to show all the processes, and there it is. I can see it, and I'm going to try and kill it from this side actually. It doesn't want to die. So sometimes that is a problem. What we may have to do is send a certain signal over to that process. So what I can do is I can do a kill -L and then kill. that finally killed it. So I had to actually send it that signal that said kill, not just um, the kill program. So okay, sometimes that has to happen. It doesn't want to quit gracefully, and maybe it's waiting for some input or reading something. But that's just an example of using the process command to see the processes, using the kill command, sending signals, the process file system, and redirecting output over to a terminal, a different terminal. So I can redirect output anywhere actually, but this is just an example of why I might want to do that. Let's say I had a particular terminal that was redirected somewhere else to a file, to another screen, and I wanted to push all information to a specific place. Or maybe I wanted to send everything that a program sends as output over to a special log file to debug it. That's a perfect example of using that process. So this is just another quick example of how you can use Linux to your advantage and what you should look for and some of the commands that you use.